Welcome everyone to Dr. MDS Academy. Here I am going to show you an animations in which two plates, one is at T1 temperature, another is at T2 temperature. See here. So the resistance we had seen in the lecture, we have a surface resistance of expression 1 minus epsilon 1 upon epsilon 1 for the surface 1. Same happens for the surface 2, and in between we are having a 1 by f12 is the space resistance. This is for the condition where no cells present. Now below here in the picture you will find there is one cell present in between the T1 and T2 body surface temperatures. Okay. So mainly the purpose of using the cell is to decrease the heat transfer rate. So as we will insert a cell in between the two surfaces, we will be having a many number of resistance. So more is the resistance, lesser will be the heat transfer rate. So as we had seen that Q is inversely proportional to 1 by RT. RT is what? Resistance. So below here you will find one applications in which a vacuum seal is present in between the inside and outside chamber. Okay, why it is vacuum sealed? Because to reduce the heat transfer rate. So the inside the fluid, which is whatever the temperature it will be, if it is warm it will remain warm for the longer period of time. So mainly the insulator or the vacuum provided, the main purpose of providing the vacuum is to increase the resistance, or as a result it will decrease the heat transfer rate. So the expressions which we had derived was this one: Q12 upon from 1 to 2 heat transfer rate is taking place from per unit area. So this is the below is the resistance. So in terms of the F12, if it is F11, F12 is equal to 1, then it will be take as a shape. But this is the universal one. Okay, if I am considering the F12. So in animation, see here, so stop the animations. See in the animations, T1 is the temperature of this surface, left one, and T2 is the temperature Kelvin given for the surface 2. Okay, epsilon 1 is the this one. See the T1 temperature I am varying. See the temperature is varying for the T1 cases for the left orange one. Okay, T2 is this one. Okay, right one. Now epsilon 1 is the immiscibility for the surface 1 here. This one. So currently 0.32 it is. So vary it. See the values is varying. Okay. Similarly, emissivity is for the surface 2 here. Okay. See, currently it is at 0.65. Now decrease the 0.33. Now 0.16. Okay. Like this, we can vary the emissivity of the surface 2. Now what is F12? F12 is from 1 to 2. Okay. How much view factor is? This below you will find 0, 1, 2, 3, 4. 0 means number of cells we have provided. So currently I am just at 0, means there is no cells in between the 1 and 2 surface. If it is 1, one cell I have provided with emissivity 0.12. I can vary the emissivity of this cell, this middle one plate. Okay, I can change the emissivity of this one. Okay, similarly I can place a 2 cells also, 2 plates also, okay, in between the 1 and 2, and similarly I can place a 3 also, okay, having the same emissivity 0 0.7, 0 0.7, 0 0.7, 0 0.7, 0 0.7. Okay, so currently I am using only one here, so the pictures showing something like this. Okay, the safe factor is what? Safe factor is the ray which is coming out from 1 to 2 is completely being or देखा जा रहा है T2 पर. Okay, like this. If it is at 0.12 means some ray is spreading outside. Okay, if it is 1, what does it means? The whole ray coming out from the 1 is captured by or capturing by the T2 surface. Okay, So this is the meaning of that. Generally we keep it 1. Okay, because we assume that for the two parallel plates, whole ray is coming from one is absorbed by the T2 surface. Okay. Below you'll find Q no shelled, means in when there is no shelled or no barrier in between the surface and one two, the amount of heat, okay, rate per unit area, what is the rate, heat rate per unit area is given as this much value. Okay, so this is for the no shelled case and this is for the shelled case when there is shelled provided. Okay, so here Q upon A, okay, you will find EB1. Okay, similarly what we had seen the lecture, okay, this expression, okay, the same expression here, EB1 minus EB2 upon the number of resistance. This is for the first one is for this surface one. Okay, the same expression, R1 is equal to 1 minus epsilon 1 upon epsilon 2. Okay, now here R2 is what? R2 is this one, F12, space resistance 1 by F12. R3 is what? R2 is what? 1 by epsilon 2 upon epsilon for this surface resistance. Okay, means for the this surface resistance, this expression for this one. Okay, this is the case for the no shelled. It means that if there is no shelled, then this is the space resistance. Okay, space resistance value. And and another one here for this one, last expression is for this surface resistance. Okay, now let's understand from the animations. Okay, so more is the T1 value here, more is the T1 value. Okay, more, see the heat rate you will find here in the slider scale value. Okay, more is the T1 value, more is the what, more is the heat transfer rate is taking place. Okay, so currently the two values are equal, it means that maximum rate. Okay, there is no zero I have put, so no cell in between that. Similarly, if I am just keep it here at 800. Okay, T2 I am just varying, decreasing. Okay, see the variation in heat transfer rate. Immiscibility, more is the immiscibility. Okay, you will find the more is the heat transfer rate, means more the amount of heat is being radiated by the surface one. See, similarly for the immiscibility too. Okay, see here the expressions. Okay, so immiscibility. Now let's switch for the Q, number of cells I am putting in between the surface 1 and 2. Let's click it here 1. So by placing a one surface here in between the 1 and 2, see the heat transfer rate how it is being affected. Okay, so see here, in case of no shelled, okay, in case of no shelled, what was the value? See, I am clicking 0 here. So the in case of no shelled or no barrier in between 1 and 2, the total amount of heat rate flowing was 4300. Now I'm clicking 1 or placing one shelled in between that. So how the values is being changed? 4300 to, okay, 3671. It means that after inserting a shell in between 1 and 2, okay, the amount of heat flow rate is being reduced. How much? 43002 to 3671. Okay, now place another second shell. See, again the further the amount of heat rate is reduced. Okay, 3203. Now placing 3, again it is reduced 2841. You here you can see also. Now first 0, once again I am wearing 0, then this will without cell, this will change. Now this one, see this one value is changing, 361, 3671. Now it is decreasing 32, 28. Okay, like this. So let's place two cells. Okay, see the value, see the how the variation is taking place. Okay, see T2 temperature I am varying. Okay, immiscibility I am changing. Okay, similarly immiscibility for the second surface I am changing. Okay, for the immiscibility of third one I am changing. More is the immiscibility, more amount of heat will see. Immiscibility for 3 1 means this one middle one I am increasing. See this shelled one, this value is currently as 1297. The same value is reflecting here also. I am increasing. So more is the immiscibility, more is the amount of heat is being radiated. Okay, so by placing a 3, let's play this video in auto mode. See how it is being changed. Simultaneously you can find out the from eb1 value, eb2 value. Okay, how much energy is being radiated by the this this one surface 1, and eb2 means from here 2 to 1, how much being surface heat is being, rate flow is changing. So this was all about the heat interaction taking place in between the two parallel plates, keeping number of cells in between that. For zero cases, see here, for the zero cases, see here how the heat flow rate is being changing. Okay, I am keeping one shelled in between that. See the how the heat flow rate is being changing. One complete cycle happen. Okay, now now I'm placing two shells in between that. The two cells I have put. See how the heat flow rate is being changing. Now placing a hard shell also. See here, I have placed third one. Keeping all other variables remain as it is. So this was all about the heat interactions taking place in between the two parallel plates by providing a number of shells. Okay, in case of radiations. So thank you all.